Hello friends of HashData, now let me walk you through how the control console works in HashData step by step. This is the main page of the HashData Management Console, CloudManager, providing an overview of the entire HashData cluster. The Overview section allows users to view the current cluster status, health, billing, alerts, and ticket information. The Warehouses section focuses on creating, viewing, and managing HashData databases, with detailed functionalities to be demonstrated later. Contact groups primarily involve setting up alert notifications. Users can add relevant contacts to these groups for subsequent alert settings. Tasks allow viewing operation logs of all database clusters, starting, stopping, scaling, and more, for centralized management. Under System Management, Tenants manages tenant information, permissions, and object storage configurations for HashData CloudManager login. You can also set up and adjust teams, users, and resource pool under Tenants section. In Operations Management, Overview displays all relevant operational information like cluster health, console service status, and alerts. Alert section shows specific alert situations for further actions. Troubleshooting provides detailed fault information and failure recovery status. Console reveals CloudManager service health. Auto Operations allows setting thresholds for cluster operation conditions and actions after thresholds are exceeded. The next step demonstrates how we create metadata catalog and data warehouse clusters. Creating a metadata cluster begins with clicking Create Catalog, selecting resource pools, naming the catalog cluster, and fill in description. Choose Next and it enters into Service Config. Choose Object Storage, Compute Cluster Scale, Default Name, Username and Password. Choose Next Components Config, choose Relevant Server. Catalog Cluster contains etcd, Catalog and FoundationDB components. Choose server based on your needs. Choose Next and enters into Overview. Check the previously selected configuration and click Confirm to create. Then the cluster starts building up and shows creating. Now the catalog cluster has been created. It shows started and status as healthy. Next let us create warehouse cluster. Click Create Warehouse. Choose Resource Pool, name warehouse cluster and fill in description. Choose Next and enter Service Config. Choose Share Catalog, and on the catalog cluster we just created. Choose Number Segments for computing. Choose Next and enters Components Config. Choose Relevant Server on Master and Segment. Here we show an example of one master and two segments. Choose Next and enters Overview. Check the previously selected configuration and click Confirm to create. Now it starts creating a warehouse cluster and shows creating. Now the warehouse cluster has been created. It shows started and status as healthy. Next let us operate on the created warehouse cluster. On this page, we can see the information of the cluster, including status and information of every node. By clicking More Operations, we can perform operations like start, stop, scale out, scale in, modify description and delete. Next let us do a scale out. Click Scale Out. Increase the number of segment for this warehouse cluster. Click to add a new server into the cluster. Now it starts scaling out. The status shows it is scaling out. We can also check the status in the Logs section. The cluster has completed a scaling out action and shows as started. We can check the cluster info, and now it shows that the number of segment has increased from 2 to 3. Next, let us do a scale in. Click Scale in. Choose the server we want to scale in and clicks OK. Now it starts scaling in. We can also check the status in the logs section. The cluster has completed a scaling in action and the log shows as successful. Now the status shows as started. Next, let us introduce the alert rules. You can set up alerts based on your needs, including default alert, service status change alert, job failure alert, etc. It also supports user-defined alerts. You can add alert rule freely. For example, it can send alerts when CPU usage exceeds a bar. When alerts appear, they can be delivered to users by multiple channels, including emails as mostly used. Next, let us show how failure recovery works. Now we have two computing segments. We set one of them as failure as a simulation. Directly log into the host from the backend to where this node is located. Turn off this host to simulate a host failure. Now let us see how the accident is handled. At this time, the CloudManager console has sensed a fault in the data warehouse cluster. The health status shows as out of service. The state machine status also shows abnormal for this segment. Fault recovery has displayed information on the failure accident. Next, the system is excluding the fault automatically. Let us see the results. It shows as fault recovery successful. The state machine status also shows abnormal for this segment and all segments. Cluster status shows as healthy as well. If we check the logs, we can see all the operations done during the accident. First is to scale in, set up a quarantine to exclude the node. The next step is to scale out, take a new server from the resource pool to replace the failed one. Now, the number of computing segment in the data warehouse cluster remains unchanged, but in fact, one of the computing segment has been replaced. The data warehouse cluster status shows as started, completing the fault recovery of the cluster. As long as the resources are sufficient in the pool, the cluster can run fault recovery without manual intervention. Next, let us demonstrate one data, namely how we share the exact copy of data among different clusters. We have set up two clusters, Warehouse 1 and Warehouse 2. The catalog cluster ID and master node IP are the same for the two clusters. Next, we log in the two clusters through the cliental portal. Create a table in Warehouse 1, table name is test. Fields are ID and name, and insert one record. Query data in table test in Warehouse 1. Similarly, query data in table test in Warehouse 2. The results queried in Warehouse 2 are completely consistent with Warehouse 1. Insert one record into table test in Warehouse 2. Query data in table test in Warehouse 2. Again, query data in table test in Warehouse 1. And it is completely consistent with Warehouse 2. The demonstration above showed that different clusters of HashData share the same data. Next, let us show the transaction consistency across different clusters in HashData. Start a transaction in Warehouse 1. Insert a record into table test in Warehouse 1. The newly added record can be queried in Warehouse 1. Since Warehouse 1 has not committed the transaction, the newly added record cannot be queried in Warehouse 2. Commit the transaction in Warehouse 1. At this time, the newly added record can be queried in Warehouse 2, hence different clusters of HashData can achieve transaction consistency. HashData CloudManager provides a web-based management interface. Users can not only easily start and stop database services by simply clicking, but also perform database scaling, node performance monitoring, and other functions as well. All actions are in graphical interface, with the back-end operations automated, greatly reducing the operational management costs of database clusters.